Hello everyone, we've got question 2 here on Mechanics 2023. So it says a particle P has a mass of 5 kilograms. The particle is pulled along a rough plane by a horizontal force of magnitude 28 newtons. The only resistance to motion is a frictional force of magnitude F newtons, as shown in figure 1. Find the magnitude of the normal reaction on the plane on P. Okay, so first of all, first and most important thing with mechanics is let's get a sketch. That's absolutely essential in, I'd say, all mechanics questions. So we've got our particle P. It has a mass of 5 kilograms, so therefore the weight, remember weight is equal to mass times gravity, so that is 5g. We have a normal reaction there. We've got a force of 28 newtons pulling it to the right and a frictional force acting to the left. So if we've got to find the normal reaction of the plane on P, we need to resolve vertically. So when we resolve vertically, there are only two forces in play, R and 5g, and they're in equilibrium. So therefore R is equal to 5g. And g is 9.8, so 5 times 9.8 is 49 newtons. So that's the answer to part A. Part B. The particle is accelerating along the plane at 1.4 meters per second squared. Find the value of F. So this is going to be Newton's second law now. So we write down F equals ma. So I've chosen to resolve to the right because it's traveling to the right, because it's being pulled to the right by this force of 28 newtons. So resolving to the right, and we've got 20, it's moving to the right, so therefore that's the bigger force. So we write that one down first. So 28 take away the frictional force is equal to the mass, which is 5 times the acceleration. Okay, so from there we just add the frictional force over to one side and subtract the 5 times 1.4 off the other side. Gives us F equals 28 minus 5 times 1.4, which is 21 newtons. Okay, next part. It says the coefficient of friction between P and the plane is mu. Find the value of mu, giving your answer to two significant figures. Okay, so the object's moving, so we've got F max. Actually, it's like we're going to be using F max equals mu r because it's moving, so the frictional force is the most that it can be. So therefore, F equals mu r, our frictional force we found was 21, our r we found was 49. So rearranging the equation, mu is 21 divided by 49, which is 3/7, and as a decimal to two significant figures, that is 0.43. So there we go. That's the end of that question. I hope you found that helpful, and I'll see you in the next video.